Hello. Do you have a microphone? Hi. Okay. Let me check. Can you hear me now? Augustine? No talk, no code. I think he's going to put speakers on or something. Can you hear me now? Can you hear me? Yeah, tell me. I can't hear you.
Can you hear me?
Yeah.
Speak up. We are. Huh? Huh?
Can you hear me?
Hello.
Hello. Yeah.
Hey, Karthik,
Your voice is breaking.
speak.
No, I cannot hear anything now.
Yours. So this is the laptop. About.
Uh,
Can you hear me now?
yeah, loud and clear. No, no, nothing now. Can you hear me? Hey, can you hear me? I can't hear. Me neither. Hi, can you hear me? You guys can hear me. You guys can hear him?
Karthik, can you hear?
Yeah, I can hear you loud and clear.
Connect to the. क्या है तेरे पास विजय?
विजय है,
विजय?
HDMI भी है,
क्या है विजय?
HDMI भी है। विजय नहीं, HDMI है।
Okay, cool. Yeah, कर ले. Okay, turn you on this. That's it. एक मिनट इधर आया नहीं. आउटपुट कैसे चेंज करना है?
Okay.
Hold it. We're getting one item fixed and another one not getting. Can you up?
I can hear.
Okay. If what is the output function key on a Windows to put to a projector?
F4, I think.
F4 function F4 दबा.
This is not Windows.
If it is XP, it is F4.
No. Because it's not putting the output to it. It's not detecting only actually.
Is it
We have-
Windows 10?
Huh?
No, it's Ubuntu.
Is it Windows 10?
No, it's Ubuntu.
Ubuntu, okay. Ubuntu should directly displays, I think. Go to system settings and then go to display. I think it should have it.
Yeah.
Just a second. A display will just mirror the display and mirror display. Yeah.
You can either duplicate the.
Keep this one.
Keep this. The resolution is too high. So resolution 126 is make it 102.
Oh, sure.
Now just do apply. 1024. Yeah, projector. I think
Utah is detecting also.
no, it is detecting. Yes, you don't have show.
Change effect वो ये नहीं देखेगा.
Mirror.
ना mirroring. Mirroring मतलब लेकिन तेरा पूरा default desktop नहीं आना चाहिए. Default desktop नहीं आ रहा है ना. Mirroring बात का बात है. Hello.
Yeah, I can hear him.
वो तो वो लैपटॉप ये लैपटॉप इसको भी देना पड़ेगा तुझे सर्विस सेंटर. It's not working from the last meetup, the last talk.
What happened?
I don't know, उनकी पूरा प्रोजेक्ट है ना. कुछ तो हो ही जाता है इसमें. Even I didn't know you use Bluetooth to be on a phone call or anything. तो Bluetooth के साथ है. The mic is not working on this. But you can hear me, right?
Yeah. I can. The connection is two-way, I guess.
The outlook is
Yeah.
and then that becomes just the audio.
चल तू जरा उधर रख. That is a good point. Okay, नहीं हो रहा है उसको पर connect नहीं हो रहा.
Let the laptop be there. Let that be an audio sync.
When you open display, right, you should get.
Yeah, go
So you take the laptop there, the audio is there.
It will off. वो desktop पे चलता है, मेरा laptop नहीं है.
हाँ?
बैटरी नहीं.
तो उधर है ना कितना
तो ऑफ करके उधर जाएगा।
हाँ ये निकल ये ऑफ मत कर,
Yes,
वो ऑफ हो जाएगा। ठीक है,
मतलब क्या ये लैपटॉप नहीं है सिर्फ
डेस्कटॉप
है। ये भगवान
कैसे टाइट है वो?
ये कुछ तो है इसका। ओके उठा दे या एक काम कर उस ऊपर रख। तू बोल रहा है कि नहीं है?
Can't you share the screen controls with me?
No.
Sad.
Well, first of all, that's not the issue here. You can do a lot of things. What if we are not getting shown here? You don't know how much bridging or desi chaining we're doing here. This is we're engineering a solution despite the drawbacks. So, what is happening is the video, the projector is on my screen, but the audio is to another guy, the other third guy.
Okay.
Understood.
Okay.
Now you can see?
Yeah, I can see people.
Yeah, cool. Now you can go ahead.
Can they see the screen? Because
Yeah.
the code is.
Let me screen share. I mean, you're screen sharing or what?
I can screen share.
Yeah, screen share.
Yeah, sure. Okay. Can you guys see this? You guys, you should be able to see yourselves at least.
Yeah, okay, we can see ourselves.
Okay, cool. Should I start?
Yeah, go ahead, man. We should have started earlier.
Yeah, I know. Okay. Hello, everyone. I'm Karthik Bhatt. I'm currently working as software engineer in a company called Unicode. So I'm going to talk about threading not equal to async. Actually, the earlier session which you had, concurrency related to Python, I'm going to go backwards right now, which is I'm going to dig a little deeper into that and just show you a little bit of internal working of how concurrency works in Python. That includes a little bit about threading as well. So let's get started. Okay. So I'm going to go through the definitions to begin with so that we don't, mistake ourselves with not knowing the definitions. So I'm going to start with multiprocessing, which is, so what is multiprocessing? Two or more tasks or processes actually running simultaneously as a different process, which means they are running in a different processors. And so yeah, two or more processor cores are used simultaneously. Okay. And we have multi-threading, which means execution path. A process can have several threads. A thread is execution path in a process, and two or more tasks can run simultaneously in multiple threads. Okay. So yeah, two or more threads are used. Simple that. Asynchronous multitasking. So if two or more tasks run simultaneously without an intervention of kernel or OS, then it is called multitasking, asynchronous multitasking, when it runs it only on a single thread and a single core. Am I clear? Yeah?
Yeah. Go ahead.
Okay, thanks. I would like to have some interaction as well in between, so don't hold back. Okay, so I'm going to go over preemptive multitasking and cooperative multitasking next, which is in preemptive multitasking is multitasking, but the task is handled, which task should be executed and things like that are handled by the OS. Okay, and in cooperative multitasking is the other way. I mean, the tasks itself cooperate with each other and they are going to give some space for another task to execute. Basically, tasks cooperate with each other. If I have to give you an example, it's a very simple example. You guys go to a hotel where billing is done first. So what happens is, suppose you are waiting in a queue. There is one person in front of you waiting, getting his bill done. Okay, and he is still thinking whether he should buy the food or which food he should buy. Okay, and suppose if the person in the counter tells him to wait or decide and come back later and moves you ahead, that is preemptive multitasking, which means here the person in the billing counter is the OS who is interrupting the first task, that is the guy who is deciding what he wants to order, and pushing the second task forward, saying, hey, you can go first, we'll bill that guy later. Okay, that is preemptive multitasking. Now cooperative multitasking, on the other hand, is like when I am standing in a queue and someone else is behind me and I am not done deciding my order, I just let him go front and pick up his order. If he has, if he has decided he'll order, otherwise he will again give back the control to me, which is in which case I'll go and order again. So that's how cooperative multitasking works. Basically, there is no intervention by the CPU or the OS, I mean kernel, basically. And in preemptive multitasking, context switching happens, and the OS resumes the suspended process, and the controlling is done by the OS. Basically, in cooperative, it's totally dependent on the task. Okay. So let me go to couple of terminologies as well. There is, yeah. Oh shit. Okay, my bad. Okay. So far so clear? Cool.
Yeah.
Let me go to terminologies, parallelism and concurrency. Okay. If you look at it in the dictionary, right, you will find exact same definitions for parallelism and concurrency. But the computer techies actually have a slightly different definitions for both of this. Parallelism is one when two processes are executing separately, simultaneously, which means the start time and not the end time. Start time is of both the processes exactly the same. Okay, so it's like having two billing counters and two people going to two different billing counters. Clear? Yeah. So concurrency, on the other hand, is a little bit different when it comes to programming. Concurrency is like how I said cooperative multitasking. One task starts, and while that task is on the flight, the other task starts, which means both the tasks doesn't start at the same time. They start at two different start point, end probably same or different end point. It's not possible probably, I mean, at the same end time, but I'm just giving a terminology. So I'll go through it later in specific. Okay, those two are set. Next, generators and coroutines. Okay, so generators in Python, we have two kinds actually. We have generators which we create using kind of a list comprehension, and we can create our own built-in functions which yields generator. Right? We use yield where keyword to create generator functions. Is there any doubt? No. Okay. I just hear a background voice and I ended up reacting. Okay. So generators, you can send values to generator, or you can receive a return value from a generator. Okay. So I'm not going to show how to use send and next, but I'm going to go through a little bit of generators in between. So then there are coroutines. Okay. Coroutines are basically a subroutine which can be suspended and resumed. Okay, it's the definition of coroutine. A subroutine that can be suspended and resumed at any point. Okay, so Python 3.4 the coroutines of async IO framework are made from three things: the future, yield from, and generators. Okay, async IO.coroutine. And in Python 3.5 plus, we have async keyword and await keyword that will actually give you a coroutine object. So in case if you want to check it, if you write async followed by await keyword consisting function and check the type of the function, once you initialize, you will get a coroutine object. Okay, clear, right?
Yes.
Okay, cool. So why synchronous tasks are slow? I'm pretty sure you already know that. The reason would be the second person has to wait for the first person to decide and do the billing, right? So I'm not going to spend much time on this. So what makes async faster? Okay, so I have put up a little bit of animation here. So this is the task queue and the CPU. So the first task comes, okay, to the CPU. It immediately starts executing it. Okay. Now, suppose the second task comes and the first task is waiting for an IO or something else. It's basically waiting for something. Then it gets suspended. Okay. And then the second task starts executing. Okay, this is the third task coming into queue, but it's not really important. But what happens is once the second task finishes executing, if it is first in first out queue, then the third task starts executing. If it is priority based, then the suspended task gets resumed and it starts executing. So you can customize it based on your requirement. Okay. Constraints for async. Okay, I'm not going to go through this right now. Let me just start with coding. Okay. From here onwards, it will be purely code based. So there will be very little bit of slides. So let me check. Okay. So I'm going to show, I have written a framework. I have taken the liberty to write the code pre-meet so that you don't have to wait for me to write the code. But I have written a custom async operation related framework myself, so that you can see what is happening in async, right? Okay, let me check. Where should I start? Okay, let me start here. It sounds good. Okay, so let me start with the generator functions also, so that I can explain you what generator function is. Can you see IPython? Yeah, cool. So I'm going to write a generator function quickly. And it's not going to take anything. And all it's going to do is going to return a set of odd numbers. So I equal to 1 while true, yield I plus equal to 1. Okay. So this is a generator function. Let me create a generator object now. So if I do type of generator, it is going to give me generator. Clear? Good. So next, what I'm going to do is either I can do a for loop or I can do a next function. So first, what I'm going to do is let me show where is the last instruction pointed. So there are a couple of things you might need to know. So okay, generator dot gi frame dot, I think its last instruction is here. F last instruction. So this is the last instruction. So last instruction initially before the generator is when the generator is initialized is points to -1. Okay, and the code dot f code, I think. Check it again. Oh, sorry, my bad. Pi frame dot. Is there a code? Yeah, F code. Generator function code object line 1 dot code. So this is the bytecode what your generator contains. Okay. So if I do a len of this, my bad. It consists 28 bytes. Okay. So let me do a next of generator. It yielded me 1 because it had to yield I equal to 1 while true, yield I. So it has yielded. Now if I check the generator last instruction, it's at byte 8. Now from here onwards, it's going to give me byte 8 itself because it stops at yield. The state is preserved at yield, and it starts from I equal to I plus 1. So that's a little bit about generator. Okay. Yeah. So let me come back to this code which I was talking about. Okay. So I'm going to start with Lucas. Lucas is a sequence just like Fibonacci, but the starting point A is 2. Okay. So what it does is it yields A, which means if the first element is it's going to return is 2. After that, it's going to return 1. After that, it's going to increment the A and B, which is A will be 1 and B will be 3. So again, after that, it will be, yeah.
Kanti, can you change the background to white? It's not visible.
Yeah, sure. All right. Appearance and behavior appearance. Default. Apply. Is it visible now?
Yeah, just increase the font size.
Okay. Oh my God. Oh, that's not it. How do I close this?
You know,
I'll show it in the GitHub. Never mind.
what happened?
I'll show it in GitHub.
Okay, okay.
No, not this.
Which level of fruit can you new free code can or like sorry, your first time in free code can? Yes, first. No, but I will have a place to it. No, I'm coding. Yes, it's something in the chapter. Yes. I'm like I just started like a couple of days. Okay. So I don't know whether you're aware, I mean there is also a session for free code camp, which is actually right now so good. You know what is it? Actually, you can go free code camp. See, free code camp is not a talk, okay? You will have to, if you are not a full stack developer, you can, there's an online, it's on this website.
I have completed the challenge.
Which chapters?
I'm building right now. I'm building the portfolio page.
Yeah, the first challenge.
Can you guys see now?
Hello?
Can you guys see now?
Oh yeah, hold it. My battery is getting low.
Okay.
There is no without last. That's actually a touchscreen. Yeah. Kundu का कहाँ है? क्या driver the Kundu place? What looks like? तेरे कौन से है boss?
Let me know when you guys are ready.
We are ready.
Okay, cool. I'll start. So yeah, this is the Lucas series. Okay, it's written as a generator, and I have written a is prime function which contains is prime, which returns is prime of a number. Okay, it returns whether it is a true or false, and then I have one print results which takes an iterable, an async function such as is prime, okay, and the task name so that I can print which task gave me the result back. Okay. Let me see. Okay, there is one more function called async sleep, which I have written as a supplementary for async io.sleep. So what it does is it takes interval and it gets a start time and end time, and when end is less than time.time, which is now, it breaks. Otherwise, it keeps yielding. Okay. So yeah, guys.
Yes, Swati, go ahead.
Okay. So this async sleep function in particular yields when we send interval as 0, it yields at least once. Okay, I mean it yields exactly once, not at least. Okay, but if you send any other interval which is greater than 0, then it will yield at least once. Okay, and then there is one print reminder function which accepts a message and interval, and it will print the message upon at a particular interval. Okay, so interval can be some seconds, number of seconds. Okay, so I have written a task class. Before I go to task class, let me go back to the code and do some stuff. Okay, this is still not visible, right? And it's useless if it is not. Can you guys see now the code? Guys, can you guys see code? Yeah. Okay, cool. So what I have done is I have written couple of functions put together, and I have written a task class which basically accepts a generator. Okay, and then there is this is the task class. It's very simple. Okay, and then there is a scheduler which contains 3 queues basically. One is ready task, one is success task, and failed task. Okay, and the scheduler has one more function called add task, which accepts a generator, which I'll go through later. Let me go through the scheduler itself. So I'll create a scheduler first, then I'll add a task which accepts a generator. So this print reminder sends me back a generator. Okay, and it prints async message. Let me change the message. Okay, it prints async message. I mean, this is async Python meetup message and 3 seconds delay. Okay, so every 3 seconds it will keep printing your async this message. Okay, then there is add task which will send the Lucas, is prime, and the task name. Okay, this will basically what it will do is will go send the iterable Lucas generator. For each item in Lucas generator, it will match if it is, check if it is prime, which is the is prime function, and if it is prime, it will say found item in task. Otherwise, it will yield. So let me run this function. So it's printing, and the first message was, "Hey, this is Python async meetup." Now after 3 seconds again. So as we go further and further, it will get delayed. So if you see here, this should have already printed. This is Python async meetup, but it didn't. So I'm going to stop this. I'm not going to wait for the next item to be found. So the reason was that this is prime function is a blocking function. It goes through int of from stu to int of mat dot square root of number plus 1 number of times, and it doesn't return back until it finds either breaks or returns true. Okay, so that is the reason why it is blocking. So let's make it async itself. Okay, what I have to do is basically I have to yield here, and I have to yield and do nothing. Then it just yields none. Okay. So since it is yielding, now it's not going to send true or false. It's going to be a function. So let me see if there is any changes I have to do. So is prime, it will come here. I don't think I have to do any changes. Let me run it again. No, I have to do some changes. It's yielding some value. Okay. Okay, here is the place where I have to do the change. So since it is yielding generator function, right, it's always going to generator object, it's always going to be true in if async function of item. Okay, so that's why I'm going to change this from yield from async. So if I do not want to keep yield from, then I'll have to do for loop here. Okay, for I in async function of item and push this yield inside. So I don't want to do that. Instead of doing that, I'll rather do yield from, which replaces the for function. And I have to remove this yield now. So match equal to yield from. Okay, if match, I have found this item. Cool. I'll run it again, and it started printing again. Let's see if it gives proper interval. I mean, the messages at proper interval. So that time it got stuck here. Now it's giving properly. Right? So it's working. Cool. Okay. So that is why a asynchronous function, once written, should never call a blocking function. So if it blocks the function, then the task which is going to be executed next will always end up waiting for the blocking function to finish. Okay. Let me explain how the run to completion works. Okay. This is a common function even used in async IO library. So what I do is, when I create an add task, the generator creates a task object, and the task object is appended to the ready queue. Okay, ready task. Now, when run to completion is called, now in our case, we have two tasks to be run. One is print reminder and print results, which both are generator objects. So while it's a ready task, which means while there is task in ready task, you pop the task, yield the next yield the generator attached to the task object. Once it is yielded, if it throws stop iteration, that means task has successfully finished. Okay. So I just get the total time used and I append it to success task. If there is an exception, then it is task has failed. Else assert yielded is none. Okay, because I am using bare yields here, just yield, right? It's going to send me none back. So assert yield is none. Self.ready task.append to task. So you push it back to the queue. Okay. So then again it will come back to while ready task. It will try to yield, and if it is none, it will append it back again, back to the queue again. Okay. This is how it is working. This is the simplest implementation possible for the asynchronous. Okay. To explain asynchronous basically. Very simple implementation this is. So I hope you have understood so far. Okay, everything good, guys?
Yeah.
Okay, nice.
Yes.
Yeah.
Okay, so I'm going to go to IO also a little bit later. Let me see if I have kept something hidden. Okay. Yeah, it's the same thing. Okay, so now that we have done this much, this will be executable in Python 3.4, I think. because we have yield from keyword. Okay. Now we are going to use the Python 3.5 plus features, which is async keyword and await. Okay. So I have already written that part. So I want to show you one thing also along with this. Okay. So if I have ever happened to create an object of, let's say, let me comment this, and let me create an object of print reminder. Okay. So coro equal to, it's a coroutine, print reminder, and what I want is a sync message and this one. Okay. And if I do print of type of coro, and let me see, let me run it. So it gives me class coroutine. Now this is a coroutine. Okay. So when you use async keyword and await, it basically gives you a coroutine. Okay. So let me uncomment whatever I have commented so far. And so the earlier code was, what we have done from earlier code is that wherever there was def, we have added a async def. Okay. And wherever there was a yield from, we have changed it to await. Okay. This is a Python built-in keyword. So now there is only await, there is no yield from. Okay. Wherever you had yield from, you replaced it with await. And I'm using async.io library.sleep now. So I don't need the old sleep function which I wrote. And I'm going to run it again. And just to make sure we haven't changed any logical stuff, we just changed the syntax. Okay. So it says, so this one gives the date time also. So every 3 seconds it's printing the message, and it is also giving the prime numbers 3, 7, 11, 29. These are prime. So okay, so I have interrupted that now. Okay, so this much is clear, right?
Yeah.
Okay, so I hope you have understood how async works little bit internally.
Yeah.
Okay, cool.
Yeah,
Now
yeah.
I'm going to go to IO operation. Now that's a funny part. I mean, interesting part, not funny, interesting. Okay, so I'll close the rest. So here, what I have done is I have used the basic models. I have written a time it function of my own, which is here at time this.py, and it contains a function called time it. Just to, it's a decorator. It's a very simple function, by the way. Anyway, let me come to this one. This is not the one I'm looking for. Is this the one? Yeah, this is the one. Okay. So I have imported socket. What I'm trying to do is I am already running a Flask server here, which I intentionally wrote and made it slower. The response time will be delayed. I have included sleep time in that. If you want to check the code, it's in flaskserver.py. By the way, you can get all this code in GitHub. It's in Mangalore Python meetup. The handle name is the Buzzy Coder. I'll share it with you later. Anyway, okay. Let me go to the thing what I was doing here. Let me remove this. So this get data basically creates a socket connection, and it connects to localhost and 5000. That's the port I have opened here. And once it is done connecting, it calls the connected. So it sends sock and path, which path is the get server code. Okay. And I create a request and send it to the sock. Now Python 3 accepts only bytes, byte type of data when you send. So it needs to be encoded to bytes from str. Okay. So I'm just replacing this path with the path which I have sent here, and HTTP 1.0/r/, and this is very important. If you miss this, it won't give you proper result. and then I call readable. Once it has become readable, what it does is it receives the chunk. It gets 2 kilobytes of data at a time, and if chunk is present, it appends to the buffer. Otherwise, it will join, close the connection, and write it into a file. Okay, this is a simple Flask server. I mean, Flask server is from server side. From client side, it's simple your application which connects to the server. So I'm going to run it. It took me 2.14 seconds, okay, and it created a file called job0 which contains the server code. Okay, so here I'm doing 2 calls at a time. Let me do 1 call at a time. So run it again, and it took me 1 second, 1.08 second. Remember, the server is made intentionally slower to respond, so it takes 1.08 seconds to respond. Okay, now suppose I wanted to do the same thing multiple times. Now this is IO, right? For 2 it took double amount of time for it. For 3 it will take triple. So you know how it goes. So we are going to implement async for this now. Okay. So let me start with this is async IO. Okay. This is the code which I have written, but it's going to be difficult to explain. So I'm going to use parallelly write it in IPython as well. Okay. Reset IPython. So what I'm going to do is I'm going to import socket here. Okay. Now, so I know the path is get server code. Let me put the path here. Get server code. Okay. And once I have put the path, I need to create a socket connection. Let me do socket dot socket. Socket accepts 2 parameters, that is AFINet and sockstring, which is default keyword arguments, so I don't have to give them. So next, what I want to do is, now I want to make it, this is a blocking code which we saw earlier. So I want to make it non-blocking. These things are blocking because connect will wait until it's connected to the server. So I want to make it blocking. So there is something called set blocking, and I'm going to set it to false. Okay. So now that I have done this, let me do sock.connect to localhost. I have to put it in ports, and connect takes a tuple, contains 2 items. Okay, error, blocking IO error. So we got a IO error saying blocking IO error. So this happens because we set blocking equal to false. This blocking IO error doesn't mean that it failed to connect. Okay, the operation is now in progress. So I'm going to the root of this socket module in CPython, and I'm going to show you what is happening here. Okay, so we have sock connect object. When we call connect, basically it calls this function internally. Okay, in Python from C module. So sock connect takes 2 items, sock object and address arrow. I mean header O. It's a tuple. They do some unpacking stuff. Okay. Now here they do pi begin allow threads, and then they do internal connect. This particular function completely runs in C. Okay. So what happens is the Python global interpreter lock is lifted at this particular place when pi begin allowed threads happen. Okay. Basically it calls release thread. Okay. I'm going to little bit of GIL as well in the meantime, so that I can explain what is happening in GIL as well. Okay. So GIL, what it does is it does not allow 2 processes, Python tasks to run at the same time. I mean, 2 different processes can run, but 2 threads at the same process cannot run at the same time, which means your multi-threading in Python is not exactly a multi-threading, but it's actually more of a simulation to the threading which is present in other languages. Okay. So what happens is your interpreter lock, this is the interpreter lock, which is for GIL. This is a useful comment by Guido van Rossum. And this is the data type of your lock, okay? And there is thread initialized, so thread init threads, okay? PyEval init threads. What happens is if interpreter lock, then return. If it is set, then return. Otherwise, you allocate the lock, okay? So before that, yeah, init threads, once the lock is allocated, you immediately acquire the lock, okay? There is no time gap between acquiring the lock and initializing, so it directly acquires the lock, okay? Then there is something called release lock, which will release the lock, okay? So basically, this is how, this is a little bit of how GIL works. So the lock is interpreter lock is created, it is acquired, and it starts, moves on with the execution. But here, when begin allow threads happen, the lock GAL is lifted, and this is the time when the other process can actually run while the current process is waiting for the IO to finish. Clear, guys?
Yeah.
Okay, cool. So what I'm going to do is now try test.connect of this guy, copy, okay. Except blocking IO error. That's what we do when we get errors. Okay, it's already connected. It took a long time, so it was already running internally. So basically this I didn't have to do, but this is what we do here. Let me show you where it is done. Okay, in get data is the first one that gets called, so I do pass. Okay, now, okay, so your async for IO is basically created using three things. Okay,
Yeah.
one is, yeah, it's your async is implemented using three particular things actually. Okay, what? Is there a problem?
No, Karthik, go ahead.
Okay. Callbacks, event loop. What was the other one? There should be one more thing, something actually. Whatever it is, I don't seem to remember it. Yeah, actually, yeah. Let's. I'll let you know once if I figure out. Okay. I don't want to stop here right now. Okay. So what I'm going to do is I'm going to create a callback. Okay. This is the callback, and okay. Before that, Python 3 provides a default selector. Okay, a package called selectors, which we use. What? Usually we use select, but Python 3 came up with multiplexing IO. So the package name is selectors, and we import default selector, event read, and event write. Okay, and this default selector when I initialize it, it gives me a selector object. So with this selector object, I can either register the socket or unregister it. Okay, there is some base selector class which default selector inherits. Okay, and that is where your register and unregister are defined. So what I'm going to do is I'm going to create a selector and register the select socket in it. So it takes file descriptor of the socket, file number. Basically, it's a file descriptor. Usually, it will be 4 or something, because 1, 2, 3 are standard in std out and error. And we are telling the selector for what event we are waiting. In this case, we are waiting for write, so event write. And there is a keyword argument called data, for which we are going to pass the callback function, okay, which will be used later. Okay, so the connected, once what happens is it will wait until the event the server is ready for write. So in the meantime, we will just create a event. Selector.select will return me the events, and this events will contain a key mask pair, and the key contains the data callback which we sent. Okay, so I'm going to modify a little bit here so that it's more readable. Callback is key.data and callback. Okay, so this is what we sent here, callback connected. So I'm just getting the callback back and just doing callback. Okay, now when the task is waiting for the server to be writable, we move to the next event and call the other callback. Okay, so the callback will call connected here in this case, right? And this connected will be called, to which sock and path will be sent. And once it is sent, we have to unregister saying that, hey, we have finished the callback, now we can proceed. Okay, and we do a sock.send of request.encode. Okay, and for this as well, this is a waiting operation, so we have to create one more callback, register the callback in the register socket, selector one more time, and this time the callback will be readable. Okay, so the readable will be called again when it is readable. In this case, we are waiting for event read, which means we wait for the socket to become readable, and from here onwards we receive the chunk. If chunk is there, we append the chunk to the buffer. Otherwise, we unregister the file number and socket, and do whatever is supposed to happen next. Okay, so every time the server becomes readable, socket becomes readable, my bad, socket becomes readable, what we do is we call back the readable function. Okay, so the event loop handles all those things. Finally, we close the selector. So let me run it. Main took 2.15 seconds. That's not supposed to happen. What went wrong? Get server code. Register, callback connected, right? Encode. Let me see, it's fine. Surprising. Oh, shock receive 1, my bad. It should be 1048. Did it work? No. Didn't create what? Let me see. Not this one. What happened? Do you guys see any problem here?
Also, if you find create subgroup within your locality, right? Andheri, so that's the reason I put that. So you know it's a lot. And if you're nearby, okay, you can decide also right to be related. And then on a Sunday,
What happened? I tested this code. It was working fine until now. Suddenly it failed.
Code model.
What?
Karthik, is the code not working?
Yeah, I can see that. It's not even writing. So something happened. It is supposed to write. It's not writing here.
Okay, let's move forward then, because it's a long day, right, for other guys.
Yeah, I agree. Let me check one more time. Oh, I think I know why it is not running. Yep, that's because I was running in the wrong file. My bad. Okay, sorry guys. I was running the wrong file. Okay. PyCharm allows you to run. It was running io_operation.py, which was not async. So that was the reason. Okay, so it took 1.9 seconds. Okay, 1.09 seconds. Let me see what happens when I give several times. Okay. Okay. Let me run it again. So 1.09 second, and it created job 0, job 1, job 2, job 3, up to job 9, all at parallel. I mean asynchronously. Yeah.
Yeah.
Great.
Okay, so that is how you can write your own asynchronous library in IO also. So things working. Cool. I freaked out for a bit. Man. Okay, so that made clear. Let me go back to something else as well. Do I have traditional PY? I had. Okay, this was how it was before, and you have thread approach also. Okay, this is your traditional, which is synchronous task, and here I have done little bit of threading and multiprocessing as well. Okay, and the get data is exactly same as before, except it's written in one single function now. So I create the socket, socket.connect, request.encode ASCII, send, right, and data receive. Until I have data, I will read it. Else, I will print whatever it gives me back. So I'm printing only the first line this time. So do you guys know while else, how it works, guys?
Yeah, tell me.
While else, do you know how it works? So basically, if you don't put a break inside the while, then I mean, if you put a break and it while exits due to break, then else won't execute. On successful completion of while loop, the else will execute. The same applies for else also. Okay. So I'm just going to show what is this about. So I have timed it, each of them. This is synchronous approach, which basically calls your get data server code twice. Then you have your thread approach, and then you have multiprocess approach. Let me run all together. Oh, sorry, it's running again the same file. So run this. So synchronous took 2.13 seconds. Thread took 1.06 second, and multiprocess took 1.1. That varies a little bit, but thread and multiprocess executes pretty much at the same time. And the thing is, each thread consumes about approximately 50 kilobytes of your memory. Okay, and the more thread you give, the more memory it consumes, because it's shared memory, right? And multiprocess, it consumes one core, right? If you have two cores, you can run two processors at the same time. If you have four cores, you can run four processors at the same time. So but you cannot scale it up to a level where you can scale thread. And thread, it consumes little bit of memory. One thread consumes 50K of memory, and it consumes more as we increase the number of threads. Okay, So async, on the other hand, consumes 3 kilobytes of memory, and it's scalable. You can run hundreds of tasks in async, right? So it's more scalable. The coding is a little bit complex, but it's more scalable. So if you're looking to build an IO based projects, you definitely can go for async, so that you can scale it. Okay, but there are drawbacks of async, which I'm going to go through, and I think that should end most of the things. So async code should be non-blocking. As I told you in isPrime function earlier, it blocks the other process. So all the async code should be non-blocking except for the main, the callers and the callee. Okay. So whether it is the caller or the callee should be asynchronous except for the main function. Async is not meant for computation. If you are running high computation things where you are not waiting, I mean, you should not go for async. It's preferable if, I mean, it is basically used for IO, okay, or database operation and things like that. When n+1 tasks are executed concurrently in async, n tasks are awaiting for some operation to complete, or IO. Okay, only one task is running, and I think that's it. Any questions?
No.
Cool. So either you guys have understood everything or you have understood nothing. I'm going with the earlier one. So
Okay.
these are the resources and references where you can get more details. You should go to mtsquad.re. There is a guy called Jesse Davis. He really explains these things really well. And I learned some of this from him. So you should check that out as well. It's really good. And he explains the internal working of Python interpreter as well. So try that out. Okay. Thank you.
Thanks a lot. Thanks. Yes.
Yeah, no problem.
Thanks.
How can I stop screen sharing?
Okay, we'll get back to you, huh?
Yeah, sure.
Yes, can you hear me?
Okay.
Yeah, bye.
Nice seeing you.